Hi, welcome to MooMooMath. Today we're going to look at applications of vectors. So there are two types we're going to focus on. The first one is when you are pulling, pushing, or lifting some weight or object, and to calculate the force that is needed or the work to be done, you just take the weight times the vector times the distance, and that will give you the work that needs to be accomplished to move the object. So the first one we're going to look at is what force is needed to lift a weight of 300 pounds 10 feet high. So again, we're going to go through the force times the vector, which is our direction, times the distance that it needs to be moved to find the work to move the object. So the first thing we're going to start with in the problem is just the weight. So the weight is the force in this case because you've got a 300-pound weight or a force that you're trying to lift. Vertically means the angle is 90 degrees because you're looking at a horizontal line, and if you lift it vertically, that is indeed 90 degrees. Therefore, the vector is going to be represented by cosine of 90 and sine of 90. And the distance you want to lift that object is 10 feet. So when we plug it into our equation, the weight or the force is 300 pounds. The vector, I'm going to rewrite this as the cosine of 90. Well, that's just 0. And the sine of 90, that is 1. So let's multiply that by the vector 0, 1. And then the distance that this is going to travel or be lifted is 10 feet high. So when you multiply all that together, you're going to get 0, 300, or 300 times the vector, times 10. So the answer, if you apply this dot product, is just 3,000. So the work is 3,000 pounds would be the answer. Okay, so let's look at a second one. To close a sliding barn door, a person has to pull a rope with a force of 50 pounds at a constant angle of 60 degrees, as shown here in the diagram. So we are pulling this rope at a 60-degree angle. We're pulling it with a force of 50 pounds, and we're going the distance of 12 feet. So it takes 12 feet to close the barn door. So the force is 50 pounds. The vector, well, what you have to think in this problem is your vector is just going in the horizontal direction. So we're just going to multiply that by cosine of the angle, and the angle is 60 degrees, since we're just looking for the horizontal work, times the distance. In this case, the distance is 12 feet. And that gives us the work to be done. So that's going to be 50. And then the cosine of 60, that's just 1/2, all times 12. So 50 times 1/2 is 25. And 25 times 12 is 300. So it takes 300 pounds to move the barn door 12 feet. Okay, here's one with a wagon. We're pulling a wagon and exerting a force of 35 pounds on the handle. And the handle is at a 30-degree angle with the horizontal ground. And how much work is going to be done to pull that 40 feet. So the force or the weight is 35. The vector, again, we're pulling in the horizontal direction. So we're going to take the cosine, which is my horizontal direction, of 30 degrees times the distance of 40 feet. So this is going to be 35 times cosine of 30 is the square root of 3 over 2 times 40. Well, this one's going to take a calculator. So let's grab a calculator here. And we're going to take, let me go back and look at the values again. Let me put them side by side here so we can see them all. So we have 35 times the cosine of 30, which we already know is square root of 3 over 2, all times 40 feet. And the work to be done would be 1,212.4 pounds. And that's the work to be done. Okay, so let's look at this next one. Finding a force. This one's a little bit different because this is talking about just a standing weight. So we have a 200-pound cart and it's sitting on a ramp inclined at 30 degrees. What force is required to keep the cart from rolling down the hill? So down the hill is actually a force. You've got to think of this as a vertical force rather, because a weight is going down on the ground. So anytime you have a weight in the vertical direction, we're going to use the sine versus the cosine. If we're pulling across, we're going to use cosine. If it's a force to be lifted up, like the very first problem, that's going to be sine. Or if it's a weight pressing down on the ground, that's also going to be sine. So in this case, we have a 200-pound cart, so that is our weight. The vector this time, we're going to use the sine, because it's a vertical direction. We're going to use the sine of 30, and we're going to multiply it. I'm sorry, there's no distance. It's just going to be holding that in place. So it's 200 times the sine of 30. Well, the sine of 30 is just 1/2. So 200 times 1/2 is 100. So it only takes 100 pounds to hold it in place. So that's the first type of problem where you're lifting or pulling. Now we're going to look at a second type of problem, and that's when you have two vectors that form a resulting vector. And in this case, I'm going to show you two ways to do these. You can do it visually or you can do it algebraically. So I'm going to start with an airplane. An airplane takes off and is to travel due east at 550 miles per hour. And the wind is blowing at 70 miles per hour at a bearing of 40 degrees. Find the plane's resulting path and the plane's direction and the magnitude. So I'm going to draw this picture first so we can get a sense of what's going on. We have a plane, it's going east, and the vector is 550 miles an hour. Then we have a wind blowing at a bearing of 40 degrees. So we have to go back and think about bearing for a moment. Bearing is always based off of north. So a bearing of 40 degrees would end up being here. Well, we have to think about it from this horizontal direction. So what angle is it making with the horizontal? Well, if this is 40 degrees, that means the angle it's making with the horizontal is actually 50 degrees. So I'm going to go back, draw my second vector, which represents the wind, and the wind is blowing at this angle. So I've got to think about the angle on the inside here. Well, if this is 50 degrees with a horizontal, this interior angle is 180 minus 50, so it's 130 degrees. Okay, now for my vectors. This is the plane, so it's going to be represented by 550 because that's the speed. And then the vector, the second vector I've drawn at the end of it represents the wind speed, which is 70. Now, I need to find the resulting path of the plane, both its direction and the magnitude. So how fast is the plane going? Well, let's go back and now draw the vector in. So the plane is actually going to take this path because the wind is blowing. So I'm going to make this, I'm going to change this to red so you guys can see the plane's path in red. So the red vector actually represents the plane's path. The speed, the direction is going, plus the wind is blowing it off course. So we want to know what the actual direction is here. So we've got to do a little work. So the first thing we want to do is figure out this distance right here, and then this distance right here. We can make this into a right triangle to figure out those directions. Okay, we could do that as a right triangle. We can also use the law of sine and cosine to figure out the red vector or the path's direction. So I'm going to start by using the law of cosine to figure out this distance. So that's going to be a squared is equal to b squared, which is 550, plus c squared, which is 70, equals minus 2 times 550 times 70 times cosine of 130. So again, I'm using the law of cosine. This is the law of cosine. And let's calculate that. So we have 550 squared plus 70 squared minus 2 times 550 times 70 times cosine of 130, which is the angle between those two vectors. And that's what, 356,894. That's a squared. So I'm going to take the square root of that to find a. So that's 597.4. So 597.4. That is the magnitude of the plane. So with the wind, we actually speed up. The plane's actually going faster. The ground speed would be 550, but with the wind, it's actually going 597.4 miles per hour. Now, we also need to know this direction. Because it's not going due east, we actually are going at this angle because the wind is blowing us. So we need to figure out this horizontal and the vertical direction to then be able to use tangent of theta. So we're going to call this angle theta to find our y direction over our x direction to figure out that angle. So how are we going to do that? Well, we have to figure out this length and width. So I'm going to now go back and do this more algebraically. So I'm going to show you the other option to figure these out. So I'm going to take 550 times the vector. Well, the vector is cosine of the angle. Well, the angle in this case is 0 and sine of 0. That represents 550 times this vector. Now, the other vector is my wind. That's 70 miles an hour. Now, you have to be careful here. Yes, we were given the fact that it's 40, the bearing is 40 degrees, but we have to use the angle as if we're looking at the unit circle. So we've got to use that cosine of 50 and sine of 50. So what I'm doing is I'm actually creating the right triangle at this point. So we know the cosine of 0 is 1, so I'm going to take 550 times the vector, 1 comma, and the sine of 0 is 0. And then I'm going to take 70 times the vector that's cosine of 50. Well, I don't know that from the unit circle, so let's go over here and do the cosine of 50. And that's let's do 0.643. 0.643. And then the second part of that is the sine of 50. So let's use our calculator and find the sine of 50. And that is 0.766. Now, I'm going to take these, I'm going to distribute them in because 550 and 70 are just scalar multiples. And that will tell me the actual vectors that are represented. So the first one is going to be 550 when I distribute it in, 0. And the second one, I'll have to use my calculator for it. I'm going to take 70 times 0.643, and that's 45.01, 45.01, and then 70 times 0.766, so 70.766, and that is 53.62. Now, I'm going to take these two vectors and I'm going to add them together because I've got the plane plus the wind. So this is 595.01, and the vector is just 0 plus 53.62 is 53.62. So what does this vector represent? That represents this purple triangle I drew. So the horizontal direction is 595.63, I'm sorry, 595, and the vertical direction is 53.62. So that's the right triangle that then would create this vector that represents the path of the plane. So this is 595.01, and this is 53.62. Now, if I do the Pythagorean Theorem, guess what I'm going to get? I'm going to get this resultant vector, 597.4. Okay, if you don't believe me, go ahead and do that. What was it, 04 or just 4 and 4? You can use the Pythagorean Theorem to find that, but we've already found it using the law of cosine. So you kind of have two options to find that. Now, the reason I needed to find the right triangle also is I need to know this angle. So I can now use the tangent theta of 53.62 all over 595.01, and I can now find my angle. So I'm going to do the inverse tangent of 53.62 divided by, the second one was 595.01, and that will give me the angle of 5.14 degrees. So 5.14 degrees is theta. Now that's how to do it the old-fashioned tangent way. Now let's go back and look at the triangle for a second. If we just look at our information, I'm going to kind of erase it just so we can look at the important information. Okay, we have, the vector here is 550. The vector over here is 70. And the angle, the interior angle is 130 degrees. And we got that from, you know, the bearing of 40, and the outside angle is 50, so this must be 130. We use the law of cosine to find out this is 5 what was it, 597? Okay, now I went back and I found the right triangle, and that's one option. But we can also use the law of cosine, or I'm sorry, the law of sine to find this angle. So at this point, we could have used the law of sine. So I'm just trying to show you some of the options. You can use the law of sine and cosine to work the triangle. You can also use the fact that you have vectors that you're adding together to get this resultant vector. So these two, the unit on oblique triangles that we studied, actually ties back to all these vector concepts. So you can use vector addition to find the right triangle and then the hypotenuse, or you can use the law of sine and cosine. So there you go. That's just when you have to add two vectors and get a resulting vector. Hope this video was helpful on your applications.